Hello, Professor. My name is Lu Huanjing. Student number is 34101176. Today, I will present my thesis, Machine Learning Based on Prediction of Netflix Customer Churn. Churn is a big problem for streaming platforms because they make money from monthly subscription. If users leave, the platform loses money. And it is also more expensive to find new users. So this study tries to predict churn before users cancel and compares several machine learning models to find the best one. I use 5,000 Netflix subscriber records, and I use Sharp to explain the main reasons for churn, so the platform can take action to keep users. On these slides, I show my objectives and research questions. First, I built and compared several machine learning models to predict Netflix customer churn. Then I evaluated the models using accuracy, precision, recall, F1 score, and AUC. After that, I improve the best model by tuning the parameters, adjusting the threshold, and using stratified k-fold cost validation. Finally, I find the main factors that cause churn and suggest the practical action to reduce churn. So my research questions are: which model works best? Does tuning and threshold improve performance? And which factors explain churn? And what can Netflix do to keep users? This slide is the literature review in Chapter 2. From previous study, we can see three important points. First, user behavior is very important. When users watch less and log in less, churn risk becomes higher. Second, ensemble models usually work better than single models. For example, random forests and gradient boosting often get better prediction results. Second, explainable AI is useful. Methods like Sharp can show why the model predicts churn. So it is early for business teams to take action. Based on three findings, Chapter 2 supports my study. So in my research, I focus on behavior and payment features, compare different models, and use explainability to help retraction decisions. This slide in Chapter 3, Data and Features. My dataset has 5,000 Netflix subscriptions and 14 variables. The tagged label is churn. 1 means churn, 0 means not churn. The data is almost balanced, and there are no missing values, so it is good for training models. I group the features into 4 parts. First is demographics, like age and gender. Second is subscription and payment, like plan type, monthly fee, and payment amounts. Third is engagement, like watch hours, average work time per day. And last, login dates. Last, in contact and preference, like devices, region, and favorite gender. The dataset works well because the classes are balanced, and the features are useful for retraction actions. This slide shows my methodology pipeline. First, I check the data and make sure the label and features are correct. Second, I do processing. I use white-hot encode and character variables, and I standardize numerical variables so the models can work properly. Third, I split the data into training and testing side using stratified sampling, so the churn and not churn ratio stay balanced. After that, I trial different machine learning models and compare them. Then I do to and threshold selection to improve performance, especially for churn detection. Finally, I use the threshold keyfold cause validation to make the result more standable. For explanation, I use feature importance and sharp, so we know which features driving churn. For evaluation, I report accuracy, precision, recall, F1 score, and AUC. This slide explains the evaluation metrics. In churn prediction, accuracy is not enough because it can look good even if we miss many churn uses. So I also use precision and recall. Precision means among users predicted as churn, how many real churn. It helps reduce false alarms. Recall means among real churn users, how many we can find. This is very important for detection. F1 score is the balance between precision and recall. On the right is the confusion metric. TP means when correctly predict churn. TN means we correctly predict state. FP means we predict churn but the user stays. F1 means we predict the state but the user accurately churns. The key point is in business, F1 is usually more costly than FP because missing churn users means losing revenue. This slide shows the model comparison results. I tested several models, including logics, regression, KA, SW, SVM, decision tree, random forest, and gradient boosting. From the table, the best model is the tool to the gradient boosting. It gives the best overall performance on the test site. The results are accuracy 0.993, precision 0.996, recall 0.990, F1 0.993, and AUC 0.9989. This means the model is very good at separating churn users and non-churn users. Also, ensemble models like random forest and gradient and KNA perform better than symbol models because they can capture more complex patterns. Most importantly, the recall is high, so we miss fewer churn users, which is more valuable for detection. This slide shows the key churn drivers and how we explain the model. First, the most important features are watch hours, average watch time per day, and the last login day. So if a user watch less and login less, the churn risk becomes high. We also see the number of portraits, subscription type, and payment method have some impact. This means price and plan level may also affect churn. To explain the results, I use the permutation importance and sharp. Permutation importance tell us the most important drivers in general. Sharp helps explain each user, so we know why the model predicts churn. In practice, Sharp can support actions. If engagement is low, we improve recommendation and content discovery. If the user is inactive, we send a reminder or engagement message. If the user is price sensitive, we can give target effect or plan change. Thank you for listening. That's all for my presentation.